Welcome to Study Loop.
Welcome to problem number 23.48, chapter 23, electric potential. In this question, we are given that there are two charges, Q1 and Q2. Q1 is fixed at some point, it cannot move, and this has charge equals to 5 into 10 to the minus 4 coulomb. And there is a Q2 charge which has been projected towards the Q1. Q2 has equals to minus 3 into 10 to the minus 4 coulomb. That means this is positive charge and this is negatively charged. This has been projected towards the Q1. The Q2 has mass equals to 4 into 10 to the minus 3 kg, and we are given that when the distance between Q1 and Q2 is zero point 0.4 meter, the velocity is equals to 800 meter per second or 800 meter per second. So we have situation as follows. So Q1 is fixed, it cannot move. The Q2 is projected with some velocity and it's negatively charged particle. So the force between Q1 and Q2 acts, and the force on Q2 by Q1 is also along the direction of the velocity here. So let's say this is F electric, or say that this is equals to FQ2, the force on Q2, which is equals to 1 by 4 pi epsilon Q1 Q2 over R square. But we don't need this formula to find out the velocity here. So our question is, when the distance between Q1 and Q2 becomes 0.20 meter, so what is the final velocity of this Q2 here? So particle reaches around zero point 0.2 meter. So let's say this is Q2 now, finally. So what is the VF now? Initially we had VI equals to 800 meter per second when the distance between them was zero point 0.4 meter. Alright, so to find out the value of the velocity here, we have to use this three formula here. So the first is kinetic energy formula, which is equals to half mv square, and the second formula is potential energy formula, which is equals to 1 by 4 pi epsilon q1 q2 over r. Q1 is a charge of the q1, q2 is a charge of the q2, and the distance r is the distance between q1 and q2. And this third formula is the conservation of energy formula. So we have k initially, the particle having kinetic energy when the distance between q1 and q2 is zero point 0.4 meter, and the potential energy ui, the potential energy 1 by 4 pi epsilon q1 q2 over r when the r is equals to zero point 0.4 meter, is equal must be equals to the final one, the finally kinetic energy here the particle the q2 has when the distance between q1 and q2 is zero point 0.2 meter. So we can find out these values here, and we can then equate with kf and then find out the value of the vf. So we have ki equals to half mv I square, ui equals to 1 by 4 pi epsilon q1 q2 over d, u finally 1 over 4 pi epsilon q1 q2 over d prime, which is the final distance. K final is equals to half mv final square. So we have to find out this quantity vf. All right, so we have k final equals to ui plus ki minus uf using this equation. Now putting all these quantities here, so we have half m v final square equals to 1 by 4 pi epsilon naught q1 q2 over d plus half mv vi square minus 1 by 4 pi epsilon naught q1 q2 over d prime. So this becomes half mv final square equals to half, finding out this value here. So we have 0.004 kg. So this is the mass of the particle into 800 meter per second square. So this is the value here, the vi. Now going to this value now. So this is equals to 9 into 10 raised to power 9. D is your zero point 0.4 meter. Q1 Q1 is your 5 into 10 raised to minus 4, and Q2 is your minus 3 into 10 raised to minus 4. So we have 5 into 10 raised to minus 4 into minus 3 into 10 raised to minus 4. Now we have minus here. So minus 9 into 10 raised to power 9.2 into 5 into 10 raised to minus 4 into minus 3 into 10 raised to minus 4. This minus minus goes plus, so let's make it plus here. So this minus comes out here. So let's finally calculate the value of the kinetic energy, or just half mv final square. So this comes out to be 4 5 4651 joule. So using calculator I have calculated here. So the value is 4651 joule, 4651 joule. So velocity Vf equals to under root 4651 over mass into 2. So we have Vf equals to under root 2 into 4651 over 0.004 kg. So the SI units of the velocity is meter per second. So we have meter per second here. So we have used the calculator again here. So we have 1520 meter per second. So that's your velocity of the Q2 when it reaches 2.2 meter. The negatively charged small object gains kinetic energy because it is attracted by the positive charge Q1, which does positive work on the object Q2. So VB, or your V final, so this final result, V final, in some books you will find out this is equals to VB, and VI is assigned as VA. In some examples in the book, it's given that Vi is equals to Va. It's just a symbol, or does a designation, doesn't matter. You can change it by yourself. You can say V2 or maybe some other name. You can give it by yourself, doesn't matter. So V finally is equals to 1520 meter per second. So that's your answer for this question. Thank you very much for your attention.